Okay, so Mateusz on his talk was using something that was called Decider. And question to you, raise your hand if you heard about Decider before his talk. Not so many? Have you been using it? Okay, so you can learn something new. Um, so Decider basically is a little bit more concrete like version of aggregate pattern, the one that you can know from domain-driven design. And it uses functional pure functions. Pure function means that there are no side effects, and for every call with specific arguments, you have guarantee that there will be always the same result. So like you cannot take something from the context. And you can think about it like some boundary that protects your changes. So here are coming call for change, which is basically command. And to proceed a command, you need some state. And state, because it is a pure function, so state cannot be like taken from the fly, from the database or something. You have to pass it explicitly. State. And as a result, you return collection of events. And we call it this function that protects the rules, a decide function. So that's one of the parts of the decider pattern. The other part is that you also have to like make an evolution of the state, because like state changes. And use it for this, you are using another function that is called evolve, like for evolution of the state. And to compute it, you take the events, or actually an event that already happened, pass it to this function, and you also pass a state that you are evolving. And then as a result, you are getting a new state. And that's actually basically decider pattern. You can connect dots, connect them, see how state is passed from one function to another, and that's a decider function, the decider pattern. You also need an initial state, which is most often just another function that starts all the process. And the thing is that because of this very concrete, structured definition, there are some mathematical consequences that actually deserve another full talk. So instead of that, I will just show you how we can implement this. So I created a game called Decide RB. I wanted to use Decider, but it's taken like for 15 years or something, and it's a competition of array sample. So like you can think about a state that is represented as a data that has ID and some name of the state. It's actually taken from aggregates repository from Arkansas. Just simplified a little. So we can open issue, we can resolve an issue. Issue can be opened, resolved, and here's the definition of decider. So we say that this is our initial state. We have a definition of the function that whenever we pass a command that is open issue on a state that is none, we have this block that to be executed. So we, for example, emit an event that issue was opened. Or we can use pattern matching, and like whenever proc returns true, that this block will be executed. So for example, we can pass in a command state. If it match, now we are emitting this event. So just a second. So there was an evolution of the function and whatever. too fast. Okay, thank you.
All right. Hi, my name is Tomasz, and I'm going to do like a short intro to OpenTelemetry. Why? Because there was like a great talk in the morning about structured logging. You might remember it or not. And I feel it deserves a bit of extra context and a bit of showing basically where we are and what we're doing, and also like how to maybe take it to the next level. But also, because the world of OpenTelemetry is kind of taking the world of web applications by storm. You might not feel it, you might not know it, but if you have like a non-trivial application with any sort of telemetry vendor or any sort of application performance monitoring like New Relic, basically if you have anything beyond plain logs piped to STD out or a file, you probably have some sort of metrics logs observability vendor. And even if you don't use it explicitly, this observability vendor is switching as we're speaking to OpenTelemetry. So we might as well know it, understand it, and use it and leverage it to actually get way more out of it and use it as a part of modern observability stack. So yeah, you're going to be users of OpenTelemetry, whether conscious or not. This is like, I hope that the conscious one's going to win. So, why we log, of course, this is a lightning talk, so we're not going to do all like why we log. Plain logs are pretty natural. Structured and semantic are way better. We can include some context, some numbers that we can, for example, like do operations on, and so on and so on. But also logs are not everything. Sometimes we need traces, especially if we have like multiple services, multiple calls. We need to be able to connect events or things happening, state changes happening when the request is going through different services. And logs are not enough because logs can give us isolated situations of what was happening on a specific service, but there's no connection between the two log statements from two different services. And yeah, there's this classical trio, 3 tabs of monitoring, metrics, logs, and traces. They all have their drawbacks listed here. Not going to read them, sorry. But what's great is now we have a standard called, an evolving standard called OpenTelemetry, where they are all facets of a basic unit called the wide event. Wide event has high cardinality, high dimensionality. Those are fancy words, basically saying we have a lot of keys and each key can have a lot of values. And yeah, they still have traces, spans, and events. Span is like a pretty cool thing because it has a timestamp, so it happened at a point in time. It has extra attributes. It can have a human readable message. Span can also, and an event can belong to a span. We're not going to be talking about schemaless databases. Yes, they are schemaless, and it's terrible as a transactional database for application, but actually for logging, monitoring, telemetry, when you don't know what sort of data we're going to be gathering right now in the future and how we're going to aggregate it or correlate it, actually schemaless databases are pretty cool for this sort of usage. So this is like an example view from a service I'm going to advertise, even though I use it a lot. This is an example trace coming from a lot of services. Those bars are spans. Those circles are actually events, and quite often that could be like log statements. You can basically see what log statement happened in exactly what context. And they all have a lot of data, both from what kind of request came in, what was happening with it, what sort of user triggered it, and and you can basically attach any arbitrary data to it from all of those services, because what's also great is that in distributed tracing, every service that's basically processing a request or anything that's happening, as long as you pass down trace ID with every subsequent call, every service should report a span on their own, passing on the same trace ID, and what's called an OpenTelemetry collector, so basically, let's say the vendor or the service that all the data gets sent to, is tasked with getting all the spans with the same trace ID, but also with parent span ID if possible, and glue them all together so that they could be shown in the sort of unified way, and you could basically have a very good insight into what's happening in our entire system, regardless of how many applications, monoliths, services, whatnot, log statements, anything we have. And yeah, it also allows us to also pretty easily, because we have a lot of dimensions, a lot of values, also allows us to pretty easily visualize it and inspect this data to see what are the anomalies. This is the screenshot from the same service. Again, I'm not going to name it, but I use it. It's great. Anyway, and it's also in Ruby. There's OpenTelemetry Ruby. We can very easily get the current span, add any arbitrary attributes we want to it. We can even send an event with a human readable title, so almost like a log, a structured log. Yeah, we can basically add an event to current span. A logger info, if you have OpenTelemetry logging integrated, it's also an event which belongs to a span, and you can basically see it all together. We can create our own traces. There's a pretty awesome book about it. I suggest you all read it. What's the catch? OpenTelemetry is new. It's an evolving standard. It's a work in progress. OpenTelemetry Ruby is pretty immature. Logging is like kind of experimental and stuff. But I suggest you'll get to it because you're still going to be using it. That's all. Thank you.
Hi, my name is Krzysztof. This is my presentation. It's about AirSpec. And it's about using the right tool for the right job and using it correctly. So basically, AirSpec, it's a big gem, it's a big tool. And it's used for specs, not which are a type of test, but not necessarily just that. Like tests and specs are not exactly the same. There is a scientific difference, if you will. Which I will not get into, but there will be a source to why this is not they should not be used as the same word. There are different things, rather specs are a subset of tests. And for tests we have different tools than RSpec. We have Minitest, which is everyone uses as Internet Explorer on Windows, so to just download another browser. We use Minitest to delete it and install RSpec mostly. At least that's my experience. I worked on a lot of projects, but I keep getting fired, and every time I go to a new company, there is always an RSpec, no matter whatever the project is. And there's also some smaller things like TestBench. There is QuickDraw, done by Joel, who did a different presentation. And RSpec is way bigger than that, than them. And so yeah, example from TestBench. This is a test. This is not a spec. Right, very simple stuff. This is just Ruby. There's no special DSL, which AirSpec has plenty of. This is Minitest in a test mode. This is Minitest in a spec mode, because Minitest is actually a tool for both test and specs. AirSpec is just for specs. And yeah, AirSpec, big tool for a specific job. You can think as a metaphor. Let's say you don't necessarily use a bazooka to kill a child, although you could. You probably could use a knife or something more efficient. Or a sledgehammer to hit a nail or whatever. If you laugh about this, your sense of humor is a bit weird, but okay. But yeah, AirSpec, not a good tool to build tests, but a lot of people kind of use it in a way that they just build tests, not specs. And to use AirSpec to build specs, you need to use its all functions, which is building custom matchers, for example. Here's the one. It's a matcher that checks if our operation returns a decorated object, which looks very simple, but does a few other things. If I get time, I'll show some code, probably won't. You have to leverage your own DSL to create actual specs, because specs are tests written for humans, basically, not for the computer. So you replace the thing at the top, which is a very boring code that you have to spend few seconds to understand that each line is doing what. But you can replace this with your own DSL that immediately tells you, I'm stubbing a policy, I'm stubbing a service. And you create some bigger helpers to have actual specs, not tests. For example, this with every combination is very useful for stuff like I have a user that can do some actions on some objects, but not on some others. Writing tests for cases like this manually either uses 200 lines, or you're doing some things with sample and collections, which is not very good. So here you kind of replace not having to write everything manually, and you also don't have to write loops, which are very hard to understand. And it can also give you better messages, outputs. I'm sorry that this is ugly, but I had very little time to prepare this presentation because I made it 3 years ago. So there was really no time. But yeah, this basically just has a more explicit message about what failed in a loop, which you would not get if this was just Ruby test that runs a loop. And yeah, there is some code. I have 50 seconds, so I won't show it. But you can ask me about it if you want later on. So yeah, closing thoughts. AirSpec is a tool for specs, not tests. And to leverage it, the for there is a quote from one of the main AirSpec maintainers, that it's a very, when you install it, it's a very bare bones thing, and you have to expand it to actually use it correctly. If you just install it and kind of try to write tests with it, not specs, you're just kind of failing at using it correctly. And that's it. Yeah.
Okay, hi everyone. Going, okay. So I want to show you some process managers at the code level. It was mentioned today several times, although Mateusz calls it automation for some reasons. So at the high level, process managers, they kind of implement the business processes, so they are very important in domain-driven design, and they orchestrate departments, and in the code it's, let's say, domains or bounded context. At the technical level, and this is where we focus right now, it's a mapping from events to commands. So we listen to some facts that happen in different departments, and then we say, okay, please, another department, please do something. So at this technical level, this is the schema, how it works. We get event at the beginning or events. We build a state from events. We make a decision, and this outputs a command, some commands. And I will use an example of reservation process, which is non-trivial, because it orchestrates pricing, or maybe better name would be sales, fulfillment of an order, and inventory, where you reserve or dispatch stuff from the inventory. So on the left side, you can see the 3 events that we are interested in. It's pricing offer accepted, order confirmed, and order canceled. And then we build a state which can be in 3 different states according to the events. And then actually there are 5 possible commands to be issued, this makes it not so trivial in general. So what are the 5 main parts of what process managers looks like in the code? First of all, we need to subscribe to those events. So we need to have this section somewhere. Then we build the state, which here in the code looks like this. We basically take the event one by one, and we use the order object here, and we create the status, and we pass along this the order lines just to be used later. So that's the building the state. The actual state is a data object, so it has just the status and order lines, and we can know what is the reserved product IDs. And then there is this act, so making the decision, that's the 4th part, where we decide based on the status what we do right now. So in the reservation process, we can reserve, we can reject the order based on the state, or we can accept the order, we can release the stock, we can dispatch the stock. So we orchestrate those 3 different domains of pricing, fulfillment, and inventory. And the commands are returned, and then they are passed to the command bus to be executed. And this is how calling a command bus looks like. So you can see 4 different commands here, which are very trivial, where we just pass the product ID or order ID. That's the simplest ones. But the more complex one is reserve stock. So this is where we try actually to make the most happy scenario, let's say. But we also want to ensure, because that's the process of when you want to ensure whether the order actually can be, whether the reservation succeeded or not. So maybe meanwhile, when we created the order, someone else took some items. And when we confirm the order, maybe we want to actually reject it at the end. So you can see that there is some logic here, where we go through all the order lines, and we iterate and we try to reserve. And if inventory succeeds with all of them, then everything is fine. But if not, we have to kind of revert everything back, because we treat it almost like a transaction. So in a way, a process manager can be treated as a transaction here. So that's some code. That's the 5 main parts. This is the hidden part, thanks to which we don't need to write it every time. So this is basically some helper methods to build the state from events. And that's the constructor where we pass event store and command bus, because we listen to events and we issue commands. And this code is taken from this repository, where you can also learn other parts of domain-driven design and event sourcing. It lives in the Rails Event Store organization under e-commerce project. And this particular class is implemented in this reservation process file. So that's it. Thank you very much.
So hi, I'm Evgeny. I work for GoHiring, and actually we are hiring, so it will be an advertisement in the end. Hopefully I'll have time. So let me share a bit of our story. So it's best to instrument on the network level. You get much of that, and actually you can get service maps like this if you use some new stuff. that's available there, or something like that. And there is actually already kernel libraries. Why it's taking so long? Like eBPF and CoreRoot. So if you have operational team, just tell them about that, and you can instrument without actually on the kernel level, so without actually instrumenting your applications. Okay, so let's go with open source backend. So for what kind of backends to use, I prefer to choose open source alternatives like Elastic and Grafana, and with OpenTelemetry standard, you can actually switch. Another good practice is to walk to std out, and you don't need to care about threading, process forking, network errors, and back pressures if you implement the client, or use the OTel libraries that actually take care of all of that. In general, library walks in Ruby ecosystem, so it's pretty useless, but you need to monitor warn and error messages for walks. And one thing we have done is actually we set a specific logger on a warn level for all library walks. Okay, give me some time. Another interesting topic is canonical logline. You can actually read more about it. And instead of having a lot of log lines, you actually have one that getting all the knowledge. And it's much easier to find. The trace ID concept, this is what in the previous presentation is about tracing. It allows you to actually manage all of the things that happen. And we have went crazy and implemented that in our log. So basically we have instrumentation, and you set the trace ID, and then you can actually see everything that's happening. So right now this is in Elastic, and I can see everything that happened from that request with all of the logs. OpenTelemetry implements that in their tracing, so it's better to use them, but there is a problem. So yeah, best practices learn from the giants like OpenTelemetry. They're trying to solve that. In Ruby ecosystem is not very mature in that, and you can use ChatGPT. I mean, it's pretty good if you ask him what is the best practices, what can I walk, and what makes sense. Some other advices, there is the concept of rate metrics, basically rate, throughput, how much request you have, the errors, the duration of the errors. And another important thing that's not there is the queue time, which you should think about, like how many workers are waiting in the queue, how many requests are waiting in the load balancer or in the Puma queue. It will give you some information if you actually have too much load and the system is not coping. And if you want to care about problems, then monitor the error and the warning logs. And another thing that we have found is more of an organizational problem, is that observability is actually a developer's problem. So it's not something that you can delegate your operational team. And if you have 20 developers and then 4 ops teams, it's just not going to scale. So try to push it as a first-class citizen. So think about what it makes for your feature to work. How you monitor that in production. Regularly scan the errors and the warning logs. Try to build some alarms of top on the logs that might scale, or maybe not, depending on your volume. And what I have found is that I think OpenTelemetry is the way of the standard, but I'm not sure it's too mature in the moment. It's not well recognized in the Ruby community in a way. And actually, yeah, I know. And actually why we have written all of this code is because that by default, the libraries actually don't work the things that we need and currently work. But I think we need a better support for observability as part even from the frameworks and even from the libraries. So that is it's not something that you have to think about, but there is always people that have spent 10, 20 years on that topic and can have this as the best practices. Yeah, I would be happy to speak with anyone that is interested. And here is our ad. If you're searching for a job, you can contact our Misha. And thank you very much.
Hi. For some of us, the job market still looks a little bit like that. Not for all of us, but you can still find a job, but maybe a promotion or a raise is a little bit higher, more difficult to find. I have some bad news. A lot of you are kind of senior and know how to code. That much is clear. But the bad news is that, like, even if your code is super performant and even if your code is clean, that's usually not going to get you a promotion at most companies beyond a certain point. So maybe you're going to get to senior, but maybe not further beyond. And I'm here to talk to you about how to get beyond that. And I don't know about you, but for me, being an engineering manager, which is like the natural progression, that kind of sucks. I prefer to stay, you know, closer to the computer and maybe solve more technical problems and kind of impact through my work rather than through, you know, other people, even though that's cool as well. So I'm here to tell you about a story that kind of helped me progress a little bit like that. Every company has a haunting problem. So like some issue that they're unable to solve. And, you know, maybe that has been a problem for years and different teams have tried to fix that problem with maybe not so much success. And we had one as well that for us, it was like billing. So it's kind of ridiculous, but when we were invoicing our clients, a lot of times the invoices would be kind of incorrect and you would have to like rerun them 3 months after the invoice was executed. And our clients would not be very happy with paying more, or sometimes they were happy when they were paying less. That depends. So there was like executive buy-in to fix that problem, and we found like the best engineers to work on that. That looked a little bit like that, and then we said, okay, you guys go and fix it. And they had like a broad skill set, and you can kind of imagine how it went. Maybe you can guess. It kind of ended up like sort of like that. So we had this amazing team, but they were not very successful at that. And like, why is it the case? Well, because no matter what they tell you, it's always a people problem. So you can take all the tech skills you might have, but if you don't focus on like what the actual problem under the problem is, you're not going to be successful. Okay, but some of you might ask, isn't this like what a PM would do? And I would argue that for some problems, a PM is actually not going to be the most effective tool to solving large organizational problems, especially when these problems are within company problems, right? So not about developing a new product of some sort, but rather about solving something that is maybe intractable and also has a severe technical aspect. All right, so this is a situation, an illustration, a basic illustration of this situation that we're in. There is somebody that is unhappy, and then you have to figure out how to make that person happy, and then hopefully you get some profit at the end. So how do you get that? Well, I'll try to be quick. First, what I did, because then I was tasked to kind of solve that problem on my own, and I made some progress, and then I had one extra person to help me out. But what I did is basically, like, you need empathy. Yes, we had a talk about domain-driven design, and that's awesome, and event storming is cool. But like, if you're not going to understand, sometimes there is no expert because you don't really know what the problem is and why the different efforts have failed. So you have to speak with, like, first identify all the people that are affected, and then speak to all of these people, interview them, talk to them one-on-one, and then understand what is the problem. And then once you understand kind of what is the surface level problem, so what people tell you, then you have to kind of understand, okay, what is the common theme behind all of these problems that people are facing, and then why have we not been able to solve it in the past? And then you have to come up with sort of a vision about of the world in which this problem is solved, and then also what is the smallest iteration that will restore somebody's faith in humanity. So like small fixes that you can start delivering and get to the solution. So in the end, it took us like 6 months, but we wrote a new billing system from scratch. We rolled it out to like 70% of our customers, and then everybody, well, it was a bumpy road, but everybody was happy ever after. If you want to learn more about that kind of approach, read this book, The Staff Engineer's Path. It's a great book. There's also a nice article, Everything is Important, so what to do when everything is important. And then if you want to contact me, my name is Karol Lewczar. You can email me. I have nothing to sell, so just to say hi, or you can also find me on LinkedIn. Thank you.
Hello, I'm Paweł Niemczyk. I was working for a quite time on my own tool, really, which is Rails Spotlight. And I would like to show you, because I was working on that and I thought, okay, maybe maybe it's useful not only for me, but maybe on someone else will have a chance to really use it. And yeah, what this is? This is a Chrome extension, and it's because we are adding, let's say, gem to our application, Rails application, of course. We can use that Chrome extension, and it's really giving us a lot of information. We can do some things with that, like let's say we have some breakdowns. We can see how fast our app is. We can check, let's say, parameters. We can check the headers. We can filter them. We can check locals, local variables, and some our own metadata, which we would like to really push in each of the requests. Also, if there are some active record queries, we can fit, we can go and check that query, we can even execute and check the results. We can ask AI on something really about that particular query. We get answer, hopefully. Yeah, it's working. And we also can execute whatever we can get from the AI, of course, if you would we would like to do that, but not recommend that. Anyway, we can create some, snippets just for us, for some reason. It's not my keyboard. Yeah, so this is one part. Also, we can have a really cool I call that console. We can ask, for example, on some, we can call Ruby code to our application where we will, that code will be executed, and we will have a response. And what is really interesting, we can have a full information about that particular instance, and even we can run some our scripts which we prepared before. Let's say we would like to change author. It's automatically getting the attributes of that object and detecting what it's coming from the app, and that's why we can execute that. And in this case, John Smith will be changed to me, let's say. So we can have our own scripts for everything what we would like to use. As well, there is an editor, which in the browser we can edit it wherever we would like. Of course, it's not recommended in some cases, but it's really working nice when we have something like, let's say, Vite with some nice views, and we would like to play around a little bit with it. So, for example, change color of the button. So we see that the button changed automatically, which is really cool. I added some nodes, so you can add some nodes in the way that also it's kind of a to-do list. Thank you. If anyone would like to really know more, you can find me after the meetings. Thank you.
Okay, so we have now like tough job market. So we talked today, whole day about the code, but no job means no code. So let's worry about this. We have to change job or we have don't contract. So we go to recruitment process. We have initial talk, we have like soft tech talk, we have tech talk, and then we get validation. You get validated, you get contract, or you don't get contract, but you don't know what to improve. Actually, yeah. So yeah, let's talk about the no part. How to get no into something meaningful. It's hard. So, yeah, it doesn't work. Okay, yeah. So in case you don't get the job, they don't tell you the truth. Yeah. Yeah, somehow. So, yeah, they negotiate with you. They don't tell you what they think about you in case you post something on LinkedIn or they're here on Ruby conference. So, yeah. Yeah, but what do you get? You get how to sell yourself. You get to how to learn. You get like sabbatical entry on resume. You reach out to your old folks. Yeah, but that's not enough. Sometimes it's like, I mean, getting job is to showing that you can deliver value, right? So let's old to your old folk, like old mentor, old team leader, someone who knows you, and who could tell you the rough truth. Yeah, and giving feedback is actually quite hard. My friend Carol, we spoke about it today. Giving negative feedback is very hard for people you don't know. You don't know how they react, and if they don't react, you don't want to. I mean, it's unpredictable. So, yeah, flavor. Reach out to someone who knows how to get the flavor out of you. And yeah, that's all. Thanks.
Tomato. Okay, so the lead vocalist in the song Rapper's Delight, one of the very first rap songs ever, was a guy who was distracted from making pizza pies. I was distracted from improving Legacy app to share what I've learned with you. So preparing a conference talk is a ton of work, but you can ship it in a finite time. It's actually 3,600 words to speak for 30 minutes, and with a tempo of 100 to 120 words per minute. This tempo is especially preferred for non-native speakers, so you can sound smart. We're all smart people, so don't be afraid. We don't need to act. Everyone has its own very unique experience and perspective. Pavel already had a presentation on Drug Meetup touching very different piece of our rewrite than the one I've presented to you today. So discover your strengths. I recommend you going to Gallup.com and taking 34 Talent one. Those are teams identified through 50 years of research. And people who take this test and discover their strengths actually are more confident, and they act better, simply. Simple as that, because of knowing yourself better. So in fact, I miss typical skills for to be a conference speaker. It turns out I like usual skills for that. Communication talent is placed lower in my strengths profile, but input, which is about gathering information, and analytical is in the top. So I can synthesize the knowledge and present complex things. Strategic talent allows me to present topics which I have expertise in. So pick the team you feel good with. I felt confident about my topic, so it happened. Learn storytelling. I don't know, go to Toastmasters meeting, go to local Ruby user group, learn it on YouTube, whatever works for you. There are so many options today. A lot of time, thanks. So, practice in front of the mirror. I especially recommend this one, not to make these weird moves and look like, I don't know who. So, we all are nervous when we all do those things when we're nervous, and you'll be much more confident if you practice. And boost your brain. You know what's the deal? Take creatine. Not for your muscles, but too. Muscles are cool. But mainly for your brain. It's the best tested supplement available. It improves short-time memory and boosts intelligence. I took mine in the morning to at least feel that I am smarter. So single-dose creatine improves cognitive performance and induces changes in cerebral high-energy phosphates during sleep deprivation. We all know that. So if you went to sleep after guiding the conference folks to kebab joint at 3 a.m., I dedicate this one to you. So the thing is that community will thank you, and I think organizers will be also thankful, especially that, yeah, the more call for papers are performed, yeah, it's the wider choice. You can pick something more interesting, maybe the talk which have never been had before. I had 40 seconds. I'm improvising right now. I'm not very good at that. What? I won't tell a joke because not to violate code of conduct. Thank you.
I decided another shot. Okay, so Ruby is mature now. How do I know? There are I see at least two signs. One, I turned 40 this week, and I'm not even the oldest developer in this room. So we are definitely mature right now, right? Second thing is how Ruby companies right now are structured. Like there are HR departments, marketing departments, budgets for different activities. And the richer actually they are, it's even harder to get any money from them. So they're definitely a mature sign. So that's why I would like to give a special shout of applause for 2N, Arkansas, and Raceware, who supported us this year. And without their support, probably this conference will not happen. So thank you.